Okay, so we have three air masses. We have highs identified and lows identified. Again, the highs are going to be places where the air mass is tall, lots of atmosphere above that location. The lows are going to be places where the atmosphere is lower, and they're also going to follow the boundaries. So the lows will be located at the bottom of the air masses at the sides. Okay, so now what we got to do is we got to figure out the convection cells inside of this. So we know that winds will go from high to low. So starting here at the surface, the winds are going to go outwards towards the edges, just like they did before. In this air mass over here, same thing. The wind is going to go out from the high towards the low. Same over here. So we've now identified the surface winds in our convection cells. Now we have to figure out what else is going on. So once the air goes together, it can't go down. The only place it can go is go up. So we see the air rising, and the air is going to rise right along that boundary between the two air masses. Same thing's going to happen here. Air is going to follow the boundary of the air masses. Now, up at the top, let's think about this for a second. This air right here is a big pile, and it's trying to even out with the low spots. So the air that's in this area right here is trying to get over to here. Well, this air is coming up. So the only way that this air is going to be able to get over to these low spots is by going down first. So, and then if we also think about it like this, think about a Jenga game. In a Jenga game, if you pull out the bottom two blocks, the whole stack falls. So in this particular case, in the center of our air mass, the air is actually sinking down. And then, of course, it's going across like this, creating our convection currents. Same thing's happening over here. I think that went off the screen. That's okay. Redraw it. Yeah, that works. Okay. And over here, air is going to sink at the high and connect into the convection currents. So we have convection currents going on inside the air masses, and those convection currents are being driven by the high air mass and the low air mass. Okay, now we're going to add in temperature. So let's think about this for a second. What kind of air sinks and what kind of air rises? So we know that warm air rises, and so the places where we have air rising is over here along the boundary. So I'm just going to put in here warm. We also have it over here, warm. And places where air is sinking is cold. So right in here, I'm going to put in cold. Over here, I'm going to put in cold. And over here, I'll put in cold. Okay, so real quick review. We have three air masses, 1, 2, and 3. The high pressure systems, or high pressure areas, are going to be located where the air mass is tall, here, here, and here. Places where the air masses are low, here and here, are going to create less pressure, and that low pressures are going to follow the boundaries down to the surface. So we're going to mark them here and here. In places where we have high pressure, we have cold air that sinks down. In places that we have low pressure, we have warm air that rises up. And that is those are regional air mass winds.